In this first example, we've got a rational function with a fraction in it, so a complex rational expression, and we do notice that it's discontinuous at 0. So we want to go ahead and simplify what we've got. I'm going to simplify this by eliminating our denominators. Now my LCD, if I look at both of those fractions, is going to include the 4 from this fraction, and it's going to include the h plus 2 quantity squared from this fraction. I need to go through and multiply everything, each term, so fraction, fraction, and my denominator by my LCD. Let's go ahead and rewrite this, multiplying that LCD through. So I've got the limit as h approaches 0. I'm going to rewrite what I had. So 1 over h plus 2 quantity squared. That needs to be multiplied by my LCD, so times the 4h plus 2 quantity squared. Now these are up in the numerator with that fraction. And then continuing with my function, I've got minus 1/4. And this is also multiplied by the LCD, so times the 4 and the h plus 2 quantity squared. Same goes in that denominator. So I have the original h, and then I multiply in the 4 and the h plus 2 squared. Now we're going to keep our eye on that prize, and that is eliminating this discontinuity at 0. So I'm really aiming to cancel that h there. Let's go ahead and simplify what we can. I can cancel the h plus 2 squared here. I can cancel the 4 in this second fraction, and that is going to leave me with this version of my function. So I have the limit as h approaches 0. I'm not going to multiply anything out in the denominator because I really want to cancel in my denominator. So I have the h times the 4 times the h plus 2 quantity squared. In my numerator, I have the 4 from the first fraction, and I've got minus 1 h plus 2 squared. So let's write minus quantity h plus 2 quantity squared. Let's keep going through the algebra. I'm going to multiply the h plus 2 squared using FOIL. So it's going to be, there's the minus in front, but it's going to be h plus 2 times h plus 2. Let's go ahead and do that in line with our problem. So we have the limit as h approaches 0. In my numerator, I have the 4 and I have the minus, and let's go ahead and multiply through this FOIL. So I have h squared plus 2h and 2h, that's 4h plus 4. And then still in the denominator, do not multiply this out because our goal is to cancel. So h plus 2 squared. Let's distribute that negative sign. Really nice things start to happen when we distribute the negative sign. So I have the limit as h approaches 0. In my numerator, let me just distribute the negative so you can see everything. So 4 minus h squared minus 4h minus 4. In our denominator, I've got the h, the 4, and the h plus 2 quantity squared. Now, the 4's cancel, so these 4's cancel here, leaving me with the minus h squared minus 4h. Let me factor a negative out of that and an h out of that. That's going to leave me with an h plus 4. You can double check me by distributing the negative h through. Now that I'm here, I can cancel. I'm going to write this just one more time so you can see what we've got. I am one step away here, maybe 2 from our answer. I have negative h plus 4. In my denominator, which I left factored, this is in time, so h times 4, h plus 2 quantity squared. I can cancel these h's, which means that my function is no longer discontinuous at 0, and I can evaluate this at 0. So I can go ahead and plug 0 into my function. Let me give ourselves just a little more room here. Evaluating this gives me negative 0 plus 4, I no longer need that limit, divided by 4, 0 plus 2 squared. So I get a negative 4 in the numerator, and I get a 4 times a 4, or a 16, and I get a negative 1/4 for our answer. Let's go ahead and do another one. So in this one, I actually have a difference of two functions. So I've got the 1 over 1 minus x, which is discontinuous at 1, becomes 1 divided by 0, and 2 also then divided by 0. We end up with this indeterminate form of infinity minus infinity. So we need to do some algebra in order to remove that discontinuity. So is it discontinuous at 1? Yes. In order to simplify this, I need a single fraction and a lowest common denominator. Now factoring this second denominator, I get 1 minus x, 1 plus x. So including each of the denominator's factors, I need a 1 minus x and a 1 plus x. I'm going to go ahead and build using my common denominators so that I can combine these two. So I get the limit as x approaches 1. I've got the 1 over 1 minus x, so it does have the first factor of my LCD. I need to multiply in the second. So I'm going to multiply in a 1 plus x over a 1 plus x. The second fraction already has the LCD that we need. I'm going to go ahead and leave it in factored form. 2 over 1 minus x, 1 plus x. Now remember, your goal is to simplify. It's to remove this discontinuity. So I'm going to leave the denominator in factored form. So watch as I continue to simplify this. So I get the limit as x approaches 1. In my first numerator, I have a 1 plus x over, I do have my common denominator. So let's go ahead and put everything over 1 minus x, 1 plus x. So I took care of the first numerator. The second numerator is the minus 2, so minus 2. That becomes, so if I simplify what I've got, this becomes x minus 1. Now it's really close to what I needed to cancel with the 1 minus x. I'm going to factor out a negative sign. So watch what I do algebraically. If I factor a negative sign out, I get negative x plus 1. If I switch the order now, I get negative and then 1 minus x. That's exactly what I need to cancel with that denominator. Let me rewrite what I've got. I'm going to give ourselves a little more room. Rewriting what we've got, we are 1.5 steps away from our answer. So my numerator is negative parenthesis 1 minus x. My denominator, which we left in factored form, is 1 minus x, 1 plus x. Now I can cancel where that discontinuity with 1 lived, and that was the 1 minus x. I can now evaluate this at 1 with a direct substitution. So evaluating this at 1, I can drop that limit. I end up with a negative or a negative 1 in the numerator and just the 1 plus x. So I'll write that as a 1 plus 1 in the denominator, and we get negative 1/2. We're going to switch gears. This is still a rational function, but this one has a radical in it. It is discontinuous at 16, so I know I need to do something to cancel this x minus 16 in the denominator. You actually have two choices. You can either multiply by a conjugate, and the conjugate would be the conjugate of the radical expression, so that would be radical x plus 4. Your other option, which I believe is easier for this example, is to factor a difference of squares. So if I were to factor that x minus 16, so x minus 16, I can think of this as radical x squared minus 4 squared, and I can actually factor that denominator. I'm going to choose the factoring method. Let's go ahead and write the limit. I'll do another example with the conjugate next. So in this, I'm going to leave that radical x minus 4 in the numerator. I'm going to factor x minus 16 as a difference of squares. So this becomes the radical x plus 4 and the radical x minus 4. If this doesn't quite sink in with you, that's okay. You can use the conjugate method, which I'm going to show you in the next example. This one does work really nicely though for me. I can cancel the radical x minus 4. It is no longer discontinuous at 16. Notice I plug a 16 in and I don't get a 0 in my denominator. So I can now use direct substitution and evaluate this at 16. Using direct substitution, I canceled everything from the numerator, so that becomes a 1. I no longer need the limit. In my denominator, I have the square root of x, or the square root of 16 plus 4. I get 1 over 4 plus 4, or a 1/8. Next, let's do one with the conjugate. So I've got another example of a rational expression with some radicals in it. I actually don't have the option of factoring here, so I am going to multiply by the conjugate of this radical expression. The conjugate is going to be the same radical expression, but instead of subtracting, I'm going to add. So radical x plus radical 8 minus x. Now, whatever I've done to the denominator, I need to also do to my numerator to keep this fraction or this function balanced. So I'm going to also multiply this same conjugate through the numerator 8 minus x. Now I've done this to create a difference of squares. Let me rewrite this. This is going to be the limit as x approaches 4. In my numerator, my goal is to cancel something. So I'm going to leave this in factored form. X minus 4, radical x plus radical 8 minus x. In my denominator, I'm going to use a difference of squares. It's the radical x squared and the radical 8 minus x squared. That minus and the plus is going to give me, let me rewrite it this way, it's going to give me the difference of squares, or a minus. So I end up with a square root of x squared minus a square root of 8 minus x squared. You could FOIL that whole thing through, but the middle terms are going to cancel for you, which makes it really nice. Again, I am leaving the numerator alone. My goal is to cancel something. So the limit is x approaches 4. I'm leaving that numerator. I'm going to simplify the denominator though. Let me write this numerator in here, 8 minus x. My denominator though becomes an x. I'm just canceling these squares and square roots, minus parenthesis 8 minus x. If I continue to simplify this denominator, I get x minus 8 plus x, which becomes 2x minus 8, which becomes 2 parenthesis x minus 4. Now, instead of rewriting all of this, this is now my new denominator. And notice how I've got the x minus 4 in the denominator, which will cancel with my x minus 4 in the numerator. Let me scroll up. We are just about to our answer. So what do we have left? We've got our limit still that we need to apply. So the limit as x approaches 4 of, I've eliminated the x minus 4. So in my numerator, I just have the radical x plus the radical 8 minus x. In the denominator, I just have the 2. This is no longer discontinuous at 4. I can do a direct substitution from here and plug in 4. That's supposed to be an equal sign, so I can just plug in 4. So I get the square root of 4 plus the square root of 8 minus 4 divided by 2. Well, this is going to be 2 plus, that next one is also a radical 4, 2, divided by 2. 2 plus 2 is 4, divided by 2 is a 2. I hope this was helpful. Take a look at my other videos on limits and Calc 1. Thanks so much for watching.